So now that we have already understood how SQLite looks at a database, basically using a file in the native operating system's file format as a database. What that means is that when we create a file, we simply use a software like SQLite Studio to create a file, or using a Python interface to create a file, which we'll learn in upcoming videos. So hang on there. Um, and when we need to remove a database, it's very simple. Just use a Windows Explorer to delete the file. Or for Mac, just use the Finder to delete the file. So it is really simple because there's no new concept called database. It's basically a file. Yeah, it's one-to-one, and we don't worry about commands such as create database, drop database, as would be necessary in a real humongous setup in a sort of commercial setting or commercial deployment of SQL Server. Now, what we want to do in this segment is to learn about 4 different operations involving the sort of transfer of data or processing of data in SQLite database. So the 4 commands are basically insert, update, delete, and retrieve, right? So, or rather select in terms of retrieving the data. So here we are looking at insert, and all these commands are basically row based. So you need to keep in mind, because SQL was developed decades ago, and the idea behind, the thinking behind is always columns are pretty much fixed. You can change them, but it's a big action. So it's rarely done unless necessary. But rows are uh, by design allowed to be expanding and shrinking much more frequently than columns. So there is not a very symmetrical treatment between columns and rows. Um, and this is something we need to keep in mind. So for example, here, when we talk about insert, right? Insert into table values, and we populate it with our data value, or we say insert into table column 3, column 2, column 4. So we kind of rearrange the order and even miss out column 1 because it is set to auto update or auto increment mode. So the integer will just automatically increase and all that. So when we insert into table with new values matching column 3, value 2, value 4, matching columns 2 and 4, we are changing the order, but we inside the database, the columns are not changed. It's just cross-matched. Yeah. So these are just different formats involving insert. But definitely, we didn't have to say insert into table by row, whatever. And by default, they are all columns. Why? Because it's very row-based kind of operations. You insert new rows, they are always new rows. Yeah. And at times when we insert the entire row, so from column 1 to column n, and we supply the data values, value 1 to value n, they are correct, they are proper, but it's duplicating, or it clashes with some existing primary key values. So there is an ID1, but you insert ID1 again. Yeah, remember the behavior of primary key. The database system basically ensures that when you declare the column to be primary key, it has to be enforced to be unique in all the values. So when we try to do that, there'll be an error, and if we don't want our SQL statements to, break halfway, like a Python script being terminated by exception, then you want to say something like insert or ignore. So insert or ignore means when there is error, ignore the insert, skip over, keep the old values. Okay. Or we can also have a variation on the insert or ignore, and use update, all right, to sort of, when there's a clash, update with the new ones. So there's an old set of values, new set of values, but except the primary key, the primary key column matched. So the rest of the values, when they are kind of different, then do you want to keep the old one or to update and override the old with the new data? So that's the the or ignore is to keep the old one, and update is to overwrite the old data with the new one. So here's an example, simple one. Insert into the customer table, values for Pete, 9 Wall Street. So because we are supplying data to all the columns, we didn't have to say column 1, column 2, column 3. So that's a convenience provided by the insert statement. Okay. So let's move into our SQLite. Okay, over here. So last time we managed to use the database to add a database, remember? So we connected this icon ABC to our actual file icon. It wasn't there, but we click a plus to create it. But if it's there, we can just select it. But if we double click on the tables, we don't see anything. So what we can do is to create table. So let me open up my file. Okay, I found my file and I'm just copying over. We haven't got any table set up, so let's go to structure to create a table. Yeah. Before we do that, let me just caution you on the tools configuration dialog here. Let's open this up. What this does is that it allows the SQL editor that we enter SQL commands into to run either one time only to enforce that no matter how many statements you enter, you run one time, or to run everything all over and again and again. Now, if you have create table, it will repeat again and again. So sometimes we just want to run one time, and it comes as default, execute only one time. So we want to unclick this one, right? Unclick this one so that whatever is seen in the SQL editor will be completely rerun again. In other words, it's what you see and what you run, something like this. So I click apply. All right, so we have no table here. One way to create a table is to right click on the table and then say create the table. And there will be this very nice user-friendly interface for us to say what's the table name. We can type customer and then start adding columns to name the columns. I want the first column to be this, second column to be that, and so on. So we can always add in more and more columns here and build the schema here. Remember what's a schema? The name, data type, and all the other properties. But that would defeat the purpose of learning SQL programming language, all the various syntax and commands. So let's not pamper ourselves with this. It's really nice if you want to design from scratch and as you think you create. But if we want to do things programmatically, like having our Python create dynamic tables on the fly and all that, you will need create table command, insert commands, and update commands like that. All right, so you can completely operate on the tables and rows and columns using just SQLite click and fill, as if it were an Excel operating on Excel spreadsheet. You can actually do that. Again, that's not our point. We want to learn how to programmatically do all these, because then we can put aside SQLite Studio and not be dependent on it, and we can just simply use Python to completely drive this. And how to do that is going to come up in the next section of discussion. For now, let's focus on how to really know SQL well, and we will definitely try to make use of this very nice tool called SQLite Studio. So let's close this. Instead, we'll create or open up a SQL editor. So this is more like a text interface, all right, having the top side allowing you to enter any text SQL command. So whatever we type here will be the kind of SQL command. If it works, we can just copy and paste it into our Python program next time, and it will run. And if it fails here, at least we can debug a little bit, query why, and understand the very nice, helpful error messages and not be bogged down by combing through our Python script as to where the problem lies when actually it lies inside our SQL statement. So first thing first, let's just practice creating a table. So I've just copy and pasted directly from the slide. Which slide was that? Slide 8, I think, I believe, yeah, right? So just have a look at that. And notice that all the keywords are kind of nicely highlighted to make sure that we are, it gets our attention. Next thing to note is that I've actually followed the convention of using capital letters as the commands, and for the table, I've used camel casing just to make it very visually distinct. But for SQL, actually, it's not case sensitive. So we can type this just as well. It understands there's no really red lines to tell us it's syntax error. So we can actually use capital, small case, totally not a problem. However, it does create some visual reading hardship later on if you're just reading using text file or Spider. That because we are going to keep these commands as strings in Python, Spider will not identify these SQL keywords. So it will be quite tough. I would strongly suggest that day one for you right now, definitely follow this convention. Keep to capital letters for all the SQL commands and syntax and everything. Okay, that's one point to take note. For our own tables, I stick to the convention of using camel casing. That is up to you. You can also use capital cases or lower cases. My suggestion is try not to use all capital letters for your table because it becomes quite difficult to distinguish visually from SQL keywords. Next is, as you can see, the schema is laid out here in these 3 lines. Name, type, and then the rest of the properties in no particular order. Okay, so we list in this order. So our columns will be created in this order. So column 1 will be ID, column 2 will be name, and column 3. Again, the column names, you can have any casing. I try to stick to camel casing. And for special acronyms like ID, then I will just use ID. Okay, so this part is up to us.